In this video, I'd like to give you a brief update on how you can further optimize your Claude Code setup. I'll show you my setup and what I changed or improved, and then maybe it gives you some inspiration for your own setup. So let's get started. I already told you that I normally split my claude.md file, so the project and system instructions, into two files. The one is inside my personal user folder, and the second one is always in the project folder, as is it here, right? Where I have specific instructions for the project itself, which is separate from the system instructions, which I would like to have for all the projects. That's why I like to separate those two files, because Claude is then merging them together. Then also I have a subagent setup, meaning in my agents folder I have various subagents, and there I did a change. Because so far, my process worked like that. I have a product manager who creates the product requirements document, meaning at the beginning of the project, I specify in plain English what I want, and then I have my product manager who then asks specific questions in order to clear all ambiguities, right? And then creates a PRD. And based on that, I had my technical architect, in this case this agent here. As you can see here, it's a Claude subagent using the Sonnet model in this case, which is then simply setting up, okay, what kind of architecture do we need? What's the backend, for instance, how we program that in Python, and what kind of a backend should it be, and the front end in React.js, for instance, and so on. So all this is specified in here without actually the implementation, right? That was the idea of the technical architect. He just decides how we implement it, but not that the way, how we implement it. So basically not the implementation itself. And then I had an implementation agent, and this is something I changed. Because I noticed the following. With an implementation agent, I had the problem that I had my plan, so I had individual steps in my memory bank of what the agent should tackle first and then after and so on. So that was fine, but I still got the problem of context rot or context pollution, because the context got too big. Meaning that after finishing the first task, for instance, the agent should not have all the knowledge from implementing the first task, right? That's not required when tackling the second task. And secondly, I also had the problem with the MCP servers, because I used various MCP servers. Maybe you do the same. Like, for instance, I used Playwright for testing, and I used Context 7, for instance, for fetching the latest documentation, and also GitHub MCP and so on. But if you take a look at Claude, if you /context, for instance, command, you'll see that those MCP servers, they require a lot of space in your context. And that's also something which I did not want. So basically, what did I change? Well, what I did was, at first I created another new feature implementer agent, which is this one here. Meaning, now my Claude Code instance works the following way. So after the technical architect defines, okay, what is actually the product implementation, how should it look like, and also we have a specific plan designed, which is stored in a memory bank, then a feature implementer agent is spawned and is only tackling one specific task. And after this task is finished, then this agent gets discarded and a new feature implementer agent is then instantiated. That is the idea. So the new agent then of course has not all the context from the prior agent, which is, as I said, not required, and therefore less context. And this is the idea behind that. So less context rot and a better actually implementation of the features. At least that's what I hope. I'm still in the testing environment. You can clearly see currently I'm on a project right now, it's running, but this is basically the idea I have. So simply one feature, one new feature agent. That is the idea. And all of this is done automatically. That's a great thing. So it's not on me to then say, okay, now you implement the next feature and so on. But simply that's the feature implementer itself after he's done with the feature, after he's implemented the feature, then of course he kills himself, so to speak. Then the normal or the orchestrator agent is then taking over and spawns immediately the next feature agent. And because I have a memory bank where exactly is specified, okay, this is where we are currently in the project. We have done this and this so far. And the next topic is this. So all this is stored in the memory bank. This means that the new feature implementer agent knows exactly, okay, where do I need to go next and what do I need to do? And this works so far, and I'll keep you updated. If you are interested, then feel free to subscribe to the channel and also let me know in the comments. But that's basically the idea. And I also have seen that now it is possible, you know, already, of course, for certain kinds of options for a longer period, to spawn multiple subagents in parallel. This is also a good idea, but the question you always have to ask yourself is, are these features independent or not? Because, you know, if, for instance, I first set up the backend, and for the backend, then I do some kind of testing afterwards, or something like that. You know, if you have dependent features, you cannot implement them in parallel. You always need to keep that in mind. So the next, let's say, optimization could be that I spawn multiple feature implementer at the same time, but only for those specific features which are really clearly independent, 100%, right? that is probably the next way to go, but currently, as I said, I'm at this step, and this is already fine for me right now because, as I said, all this is done without my intervention. I'm just looking at it, and at the end, of course, then I can check the application. And you can also see after this, I have also then a release manager subagent. I have a security auditor. Of course, the security auditor should at first check the code for any security flaws after that. So that is the idea behind those two agents, but I already had that in the past, so you already probably know them from a prior video if you've seen it. Now, one additional thing, as I said, regarding the MCP servers. MCP server, I mean, itself is great, but as I said, it also leads to a context rot. At least that's my point of view, because I've seen how much space they actually require in the agent's context. And that's not good. And also, I believe, I'm not sure, but I believe that, of course, if you have more context, then, of course, Claude is already is reading this all the time. And I get faster to this Claude limits, which I hit all the time with my $20 subscription, which is a pain. But maybe you face something similar. So the idea was to remove everything from the context which is not required. And this is why, instead of having my playwright MCP agent, I now have simply created a playwright skill. So in my skills directory here, I can see there are several skills, and one of them here is a playwright skill, right? So I can simply tell my agent that when we do an end-to-end testing, then call the playwright skill, and then only then is the playwright skill used, and we have this progressive disclosure, what Entrophic calls it. So it's not loaded up front in the context, but only at the end when we do the testing, or if you do the testing sooner in the project, of course, then. But the idea is that you do not load everything up front, and that's what skills are for. And that's why I thought, if you have to decide whether you want something in an MCP server, or you can alternatively use a skill for that, then always go with the skill, because it's much more efficient, and I think that's a better way to go. There are certain things, of course, where you need MCP servers probably. You cannot simply outsource that, I get that, but this is the idea. And what I also have seen from other programmers that, for instance, they don't rely on context 7. Again, this is an MCP server, but instead what they do is they simply identify upfront, okay, what are the libraries which the model currently maybe doesn't know or which were updated, and they just go to the specific website, copy the markdown code, and also paste it as files inside this directory, and also therefore reduce, again, the context size. Also an option you might want to try out yourself. So that's it for this video. Hopefully you enjoyed it. Maybe you learned something and can apply it to your own setup. Also, if you have something different or you think that I should do something different, let me know in the comments. So thanks for that. As always, please subscribe and see you in the next video.